Hi everyone, in this session we are going to see how to solve problems on fast Fourier transform. The outline of the presentation is going to be in this way. That is, I am going to solve a problem in n equal to 8 point in DIT and DIF. Similarly, n equal to 4 point in DIT and DIF. And finally, this session will end up with inverse fast Fourier transform. Before getting into the problem, we will start with the fundamental calculation, that is Twiddle factor calculation. What is Twiddle factor? We already know. Twiddle factor can be represented by using Wn. Wn is equal to e to the power of minus j 2 pi by n. This is what we have already seen in the algorithms derivation. And in general, for n equal to 8 point DIT or DIF, whether it is decimated based on time or frequency, these are going to be the Twiddle factors that we are going to use. In DIT, it becomes decimation in time. In DIF, the decimation is going to be based on frequency. No matter what is going to get decimated, the Twiddle factors won't change for both DIT and DIF. So, what is W8? How can we represent subscript 8, which is equal to e to the power of minus j 2 pi divided by n. N is actually the total number of inputs in the sequence, the length of the sequence. So, n equal to 8. When you substitute it, you get e to the power of minus j pi by 4. So, this is actually a general term which we require for all the powers of ranging from 0, 1, 2 and 3. First we will calculate W8 to the power of 0. So W8 to the power of 0 is e to the power of 0, which is equal to 1. Right. W8 to the power of 1, we already know what is W8 raised to the power of 1. So this becomes cos pi by 4 minus j sin pi by 4, which is equal to 0.707 minus j 0.707, that is cos 45 degrees minus j sin 45 degrees. Next one is W8 to the power of 2. So similarly, you do the same calculation, that is take W8, raise it to the power of 2. We get cos pi by 2 minus j sin pi by 2. Cos pi by 2 is 0, that is cos 90 is 0 and sin 90 is 1. So we get minus j. The next one is W8 to the power of 3. So raised to the power of 3, while you calculate that, you will get e to the power of minus j 3 pi divided by 4, which is equal to cos 3 pi by 4 minus j sin 3 pi by 4, which is equal to minus 0.707 minus j 0.707. So these are actually constant values of Twiddle factors that we are going to use no matter whether it is going to be decimation in time or decimation in frequency. So keep this as a key point in your mind, right? Now we shall enter the actual problems of problem solving of n equal to 8 point DIT as I specified earlier. So use the 8 point radix to DIT FFT algorithm to find the DFT of the sequence. X of n is equal to, so the sequence is given and there is no 0 pointer or any arrow marker. So the first sequence has to be considered as n equal to 0. So what is the length of the sequence? N is given as 8. So n is equal to 8 is the 8 is the actual point sequence we are going to work out now. What is actually shown here is actually the algorithm based calculation. So all these pages will give you how to calculate the decimation stages using algorithm, right? So this will be there in the video, whereas I'll take you to the easiest way to solve this problem. So as soon as you get this problem, you take a paper, turn your page to the landscape mode so that you get the diagram very clearly. Okay, so start drawing. What is the first and foremost point that we have to look at? The asked question is DIT algorithm. So for DIT algorithm, we should remember the most important thing, the input sequence should be taken in bit reversed order, whereas the output, see, look at this, whereas the output will be obtained in the normal order or natural order, whatever it is. So first draw the diagram, turning your page to landscape mode, 8 very clear lines spacing about 1.5 centimeter or 2 centimeter, it depends on you. See to that you are drawing it very neatly. Better you can draw transparent lines so that you are not going out of that boundary. Okay, so first stage, this is actually the first stage decimation, and second stage decimation, and this is the third stage decimation. So for all these 3 stages, you can better draw lines, transparent lines like this, marking the node points, right? So what is the first stage? First stage is draw a butterfly like this. Put a cross symbol like this and draw the arrow. As I told you, arrow mark represents a constant multiplier of 1. Right? Okay. So for the first input line, leave it plain. For the second input line, it has to be multiplied by -1. So do remember this. Right? Then next, draw 8 lines like this. Join every 2 points and do the same procedure. Do repeat the same procedure. So first input parameter, second input parameter, all second lines are multiplied by -1. Hope you understood the first stage. And before this, for DIT, we have seen the 2-point DIT structure. We are supposed to multiply the Twiddle factor before multiplying it by -1. That is before it is taken inside the butterfly structure. So place the Twiddle factor W in front of this butterfly structure. Right? So you might have a question, ma'am, you told in general we can have the same values, that is W8 to the power of 0, 1, 2, 3. This we can keep it common, but now you have used W2 to the power of 0. This is actually going to be taken as W8 to the power of 0, but to show in some of the textbooks they would have shown like this. So to show that I am showing you this W2 to the power of 0, whereas by using the periodicity property, the next diagram which I am going to show you will, which I am going to work out for calculation, will definitely have W8 to the power of 0. So what is the first step? Draw 8 lines at 2 centimeter apart. Take a scale and draw 2 transparent lines so that you are not moving out of the boundary. So see to that, so your graph is to be drawn like this. The next like this, 2 lines from here and 2 lines this way. Follow my pointer, right? 2 lines this way and 2 lines this way. And then, so I told you, the first one has to be considered as first input line. So since it is n by 2 now, so this first 2 lines has to be considered as the first input line, and the second 2 lines has to be considered as the second input line. So multiply it by -1 on both these 2 lines. Okay. So make this as common, right? Then last one is, once again draw 2 transparent lines so that you are not going out of the boundary, and move the arrow from this point to this point, this point to this point, this to this, and this to this. Similarly, the same way you have to draw, right? Now consider this 4 lines as one single input line, and these 4 lines have to be multiplied by -1, right? So this is how you have to draw. First try and turn the page to landscape. Only then, if something goes wrong, you will be able to locate where the problem is, right? So the next one, before the butterfly, you are supposed to fill it with the Twiddle factors. So here it is filled with W2 to the power of 0, and the next line is W4 to the power of 0. So this is first line and this is second line, right? So W4 to the power of 0, W4 to the power of 1. Similarly, the same exact replica for the next 4 lines, right? So this has to be multiplied by the Twiddle factor. So what is the general structure here? It is W8 to the power of 0. Now you can see, you will be surprised, right? So W8 to the power of 0, W8 to the power of 1, W8 to the power of 2, and W8 to the power of 3. So do remember, what is the step? Before it enters the butterfly structure, the Twiddle factor has to be multiplied. right? So this is actually the way to draw this DIT n equal to 8 point structure. So after drawing this, now come to the input section. So this is the input and this is the output. This is time domain sequence and this is frequency domain sequence. So in time domain, it has to be there in the bit reversed order. So what am I supposed to do? We have already seen how is it actually paired and how is it reversed, right? So now I'm not going to explain you that. So the order is placed like this. It is 0 and 4, 2 and 6, 1 and 5, 3 and 7. So if you just look at, there will be only one bit change when you compare these 2 points. So that is actually the thing, right? So bit reversed order. Now the input sequence given to you will be there in which order? N equal to 0, n equal to 1, n equal to 2. It will be given in the natural order. So what is that you have to do? You have to change it according to the bit reversed order. Only then you have to take the values. Otherwise you will go wrong, right? So this is how we have to draw the general block diagram. After drawing this, look at this. So this is how we are going to calculate. So what are the values? So as per our problem, x of 0 is equal to 0.707 and x of 4 is equal to minus 0.707. So the values given in the problem is filled accordingly according to the bit reversed order. Okay. So the next 2 stages are yet to get the output. So please remain as such. Okay. So first thing, follow my pointer. So first thing is, after drawing all these structures, first one is, see, W2 to the power of 0. First thing I told you, you have to fill in the basic template. So basic template it should have, see, I have mapped W2 to the power of 0 as W8 to the power of 0. So for n equal to 8 point, you should remember this, even you are asked to get up during the sleep. Okay, you are asked to say during your sleep. Okay, so W2 to the power of 0 is periodic with W8 to the power of 0. See, so I have replaced simply W2 to the power of 0 as W8 to the power of 0. Okay, then go to the next stage. Here W4 to the power of 0 is replaced by W8 to the power of 0, whereas W4 to the power of 1 is symmetric due to periodicity property, it is multiplied by 2. So W8 to the power of 2. So what is the constant element that we have to place here? W8 to the power of 0 and W8 to the power of 2. So the same thing you place it here. W8 to the power of 0 and W8 to the power of 2. And for the third stage, there is no issue. So you can simply write W8 to the power of 0, 1 and 1, 2 and 3. Okay. Hope you understood. So now your diagram will simply look at with Twiddle factors filled by W8 to the power of. Okay. Right. Now how to follow the calculations. So I have placed this bit reversed order sequence because the sequence of my question was in normal order or natural order. I have just taken the sequence. You know normally the sequence starts from n equal to 0, right? So now what is the first step in calculating the 2-point DFT? So this is the structure drawn. As mentioned earlier, the first input has to go here. So this is the first stage of calculation where I am going to store the output value. So first value is 0.707 goes to this point. Here it is minus 0.707 into what is W8 to the power of 0. You should not forget multiplying the Twiddle factor first. So minus 0.707 into W8 to the power of 0 is 1. So into 1. At this point it is minus 0.707 into W8 to the power of 0. Right? So after multiplying this, take this here. So what is there already stored here? It is minus 0.707. Plus minus 0.707. What will be the net result? Net result is 0. Right? The next one is always assume in a 2-point DFT this is A and this is B. What the first one, A only should come first. Okay, right. So at this point, how to calculate it? So A has to come first. So bring this 0.707, and what does this line represent? Simply multiply it by 1. So 0.707 into 1. Once again, it is 0.707. Right. Now come to this parameter. So this is B, right? What is the step I have to use? Minus 0.707 into twiddle factor 1, and it has to be multiplied by one more minus 1 when it is entering this butterfly structure. Okay. So multiplying it by minus 1, what will be the value? Minus 0.707 into minus 1 becomes plus 0.707, where already a 0.707 is there here. What will be the added value? This is complex addition, right? So what will be the value? 1.414. Understood? So the next, the same procedure we have to follow. So this is A, B into W8 to the power of 0. So here A plus B into W8 to the power of 0. Here it is A plus B into W8 to the power of 0 into minus 1. So this is what is happening. Now the same value I am not going to repeat. So now look at this odd sequence. First, the input is 1, right? So 1 goes directly. 1 into 1 is 1. Now what is stored here? 1 is stored. Now here minus 1 into twiddle factor is 1. It becomes minus 1. So it goes here. So 1 plus of minus 1. 1 minus 1, the value will be 0. Okay. Similarly, come along the pointer. So A, 1 has to get dropped. 1 is there. Now this is minus 1 into twiddle factor 1. It is minus 1. Once again when it enters into the butterfly, it becomes minus 1. So minus 1 into minus 1 becomes plus 1. So already what is the value dropped? 1. So 1 plus 1 becomes 2. Okay. So this is 0 and 0. So obviously the output values will be zeros. Right? What is the first stage output? These are the first stage outputs. Hope you would have understood clearly. So these are the first stage outputs. This is the procedure we are going to follow throughout. Okay. Now all these values, let's assume all these are stored in this nodes. Okay. We are going to repeat the same procedure as what we did for n equal to 2-point DFT. Right? Now let us look at the first structure. Here it is 0. So 0 is going to get dropped here. Here there is a 0. Okay. Now here is a 0. So W8 to the power of 0 is once again 1. So it is 0. 0 plus 0 becomes 0. Okay. The next line. What is the value here? It is this output is going to be the input for the next stage. So what is the input for the input at this point? It is 1.414. So 1.414 is dropped here. You can look at the diagram. It is very clearly mentioned. It is 1.414. Okay. The next one is the next input is 2. But what is that we have to do? You have to multiply it by the twiddle factor. What is W8 to the power of 2? We have already calculated. It is minus j, I guess. Right? W8 to the power of 2 is minus j. So, it is equal to 2. Yeah, sorry. There is a mistake in the problem. See, here it is 0.707. This is getting dropped here. Minus 0.707 into 1 into minus 1, that will become 0.707, which is going to be the same value. See, this is the same sequence is repeated, but wrong answer has been written. So it is 1.414. So sorry for that. So 1.414. Now what will happen? 1.414 is the input at this point. Already we have dropped 1.414 from this end, this point. Now this 1.414 into W8 to the power of 2 is minus j, right? So 1.414 into minus j into enter into the butterfly, it has to be multiplied by minus 1. Now what will be the answer? 1.414 plus j 1.414. Clear? Right. So the next one, probably I can move on to the next so that we can get the clear. Right. So this is the third point. So what is the input at this point? It is 0. And for this I need one more input point, this one. So 0. So first A has to get dropped. So 0 plus 0 into 0, 0 into 1 into minus 1. Anyway, it is going to be 0. So 0 plus 0 is 0. Right? So this is how we are calculating. The next point, I hope I have completed all these points. Right? So this is how we are calculating the first stage. Similarly, look at this stage. I will explain you. See, at this point, the input is 0. Now, I have to calculate this point. So 0 is the first input, and from where another input is coming? At this point, right? So 0 into W8 to the power of 0 is 1. So 0 into anything is 0. Now if it comes here, 0 plus 0 is 0. The next, this is the next point. So what is the input at this point? 2 is the input. So 2 goes directly after multiplying it by unit multiplier. Then from which point it has to get another input? At this point. So 0 into the Twiddle factor minus j. 0 into anything is 0. So already 2 is there. 2 plus 0 is 2. Hope you would have understood. The next one is this point. So at this point the direct input is 0. The other input has to come from here. So this is also 0. So 0 plus 0 is 0. The last point, this calculation, we need an input from this point. So this point is 2. 2 I am dropping it down. 0 into W8 to the power of 2. 0 into minus j into minus 1. So 0 into anything is 0. So 2 plus 0 is 2. Right. So this is the output of stage 2. Hope you would have understood. So this is the output of stage 2, which is going to be the input for the last stage. Very easy, right? So the last procedure is the same thing. So first input is 0. 0 has to go directly from the elevated butterfly. Look at the sequence. The other point is coming from this point. So here the input is 0 multiplied by the Twiddle factor, and then it goes up. So 0 into anything is 0. So 0 plus 0 is 0. Right? We'll come to the next point. So at this point, 1.414 minus j 1.414 goes directly. At this point, go and check where is the next input. So it has to come from this point. So here, what is going to be the value? 2 is already here. 2 into, what is W8 to the power of 1? We have already calculated, right? It is 0.707 minus j 0.707. So multiply that, add it to this value, you will get this value. Okay, what is the procedure? 2 into multiply W8 to the power of 1, which is 0.707 minus j 0.707. Take this, already a value, this one is here, plus 2 into this. So you will get finally this answer. So this is how we have to repeat the procedure for all the points. Right? So this is how we calculate a decimation in time algorithm. And for this, the output sequence is already available in the natural order. So we need not worry. At last, after calculating all these things, write the answer. The FFT of the sequence x of n is equal, for the given sequence x of n is equal to x so and so is equal to x of k is equal to start from this value and end till this value using a flower brace. And if possible, put an arrow mark for the 0 pointer, right? So this is how you have to work for an n equal to 8 point DIT FFT. Now look at this DIF. I can explain you this DIF. So what is happening in this DIF? The same thing, but there is only one difference. Now there the butterfly was slowly increasing. Here the butterfly is bigger at the first portion, whereas it is getting decimated while it goes in this way, right? So this is going to be stage 1, stage 2 and stage 3. The same procedure. As usual, 8 lines you have to draw, turn the page to landscape, draw lines and then start drawing this. Exactly the vice versa structure as we did for DIT. So draw the structure. After drawing the structure, as usual, the second set of lines have to be marked by -1, -1 and -1, multiplied by -1. The second set of lines has to be multiplied by -1. Okay, and the second line has to be multiplied by -1. So do that procedure very clearly first. In DIT, what is that we did? We multiplied the Twiddle factors with the input and then we sent for complex addition. Is it not? Here only after addition we are going to perform this Twiddle factor multiplication, right? So there is no Twiddle factor multiplication before the butterfly starts. It is only after the butterfly. So what is how are we going to write the Twiddle factors? W8 to the power of 0 will sit here, W8 to the power of 1, W8 to the power of 2 and W8 to the power of 3. Similarly, after the butterfly, the last 2 lines have to be multiplied by W8 to the power of 0 and W8 to the power of 2. The same thing here. At last it has to be multiplied by W8 to the power of 0 is equal to W8 to the power of 0, right? So this is the only change that we have to do in DIF structure. And the most important thing is the input available at DIF will be in natural order. So whatever is the sequence given to you, you simply take that sequence 2, 2, 2, 2, 2, 1, 1, 1, 1, right? So you take the same sequence and start working on it, whereas the output available, the output that we are going to get is going to be there in the bit reversed order, where this bit reversed order can be changed to the normal order while writing it, right? So what is the first step? As usual, this 2 has to go directly, and from where it is to get the next input? From here. So 2 plus 1, is it not? 2 plus 1, it is going to be 3. 2 plus 1 is going to be 3. Same thing, 2 plus 1 is going to be 3. You can look at this. This is actually the multiplied inputs to the next stage. Hope you can see this. All these are simply unit multipliers. So we have represented it by 1, right? Now here I am taking this second set of lines. Look at this. This is your n by this is actually your first stage. It is the decimation sequence. Now look at this stage. 1 goes directly from here. So it is 1, and what is the other point? Sorry, here 2 comes from here. It is 2. Now what about this point? Here it has been dropped. Look at this point. It is 1. Inside a -1 is there. So multiply it. -1. So 2 minus 1 becomes 1. After that only we are multiplying it with the Twiddle factor. So you should not forget it. So have a very good space here so as to get the output first and then multiply it by the Twiddle factors. Then place that as input in the next stage. Okay. So that is the very important thing required. So I'm getting 1. 1 multiplied by the twiddle factor 1 becomes 1. Okay. The next line, probably you will get an idea here. Now what is the next line? So from here it is getting dropped. Same 1 gets dropped here. Sorry, same 2 gets dropped here. Now 1 into minus 1 is minus 1. So what happens? 2 into 2 minus 1 is 1. Whereas 1 into, what is the twiddle factor here? It is WA to the power of 1. What is the value of WA to the power of 1? We have already seen 0.707 minus J 0.707. So that is going to be, after multiplying it with the twiddle factor, that is going to be the input for the next stage of decimation. Okay, so this multiplied value has been placed here. Hope you can see the structure. Okay, so similarly the next one and next one. Okay, so this is how we are bringing in the inputs at this stage. Once again the same procedure. So 3 is getting dropped. 3 into minus 1 is 0. 0 into 1 is 0. So 0 is placed here. So this is how we are getting all the multiplied values. And finally, do not forget there is a twiddle factor here, but don't worry, the twiddle factor is only 1 here. So whatever you get at this point is the output for the sequence. So it is there available in the bit reversed order. So this bit reversed order has to be written in the normal order. Right? So there will be one more possibility of question in this. How will you calculate the magnitude spectrum and phase spectrum? What is magnitude spectrum? Magnitude spectrum is modulus of a square, square root of a square plus b square. Is it no? So use that formula and find out all the modulus magnitude values. Whereas phase spectrum can be obtained by using angle of x of k, which is tan inverse of b by a. So apply those two things and find out what is modulus of x of k and angle of x of k. So this is how we plot magnitude spectrum and phase spectrum. Hope you all know it is a very basic thing which we have done already in DFT sequence. So I'm not going to explain all about that. Okay. So this is actually one more question in DIF. Look at the question. So questions can be of different types. Obtain the 8-point DFT of the following sequence using radix 2 DIT FFT. So the input given to us is only 2 1 2 1. Ma'am, you are telling n equal to 8-point sequence, whereas you have given only 4 inputs. Then how can I consider the next 4 inputs? So what is that we have to do? We have already studied a concept called as zero padding. So pad it with the zeros according to the length of the sequence. So padding it with zeros, you get the sequence. This is hopefully understood by you very clearly. It is there in the natural order. Natural order is no disturbance in the input. Take as it is whatever you have given. See, this is the padded zeros. So start with the structure. What is that we have to do? Landscape, transparent lines, then draw the lines inside the boundary, place the twiddle factors after the butterfly structure. That is very important. Then multiply the second set of lines by -1. So this is the procedure we have to follow. Same way you calculate it, you'll be surprised, you will get the answer very clearly. If the procedure is clean and neat, this is one of the easiest problem that carries 16 marks, and the 16 marks is there in your hand. Okay. So already we have seen 8-point DFT. What is going to be the difficulty in 4-point? What is 4-point? 4-point is the length of the sequence is 4. Let's take as example x of n is equal to 1 0 1 0. Right? So 1 0 1 0. What is the algorithm they have asked? DIT. DIT input has to be in what order? Bit reversed order. So what are the even sequences in a 4-pointer? There are only 4 inputs, right? One is 0 and the other one is 2. So club the even sequences, club the odd sequences, rearrange it and put it. What is the important point that we have to know, that we have to remember? Twiddle factor has to be multiplied before entering the butterfly structure. Okay, so place the Twiddle factor. What is the n equal to capital N length? 4. So W4 to the power of 0. Simply this is also W4 to the power of 0. So 1 goes directly. Here it is 1 into 1 becomes 1. So 1 plus 1 is 2. This is 1 comes directly. 1 into 1 into minus 1 becomes 0. So 1 minus 1 becomes 0. Okay. Here it is 0. 0 plus 0 is 0. 0 minus 0 is 0. Okay. So stage 2 is the outputs of this stage is 1 are the inputs for the stage 2. So 2 goes directly. Here it is 0. What are the Twiddle factors that have to be used here? It is only 0 and 1. So W4 to the power of 0 and W4 to the power of 1. We have already known this Twiddle factors, or if not, you can calculate it. So it is 0 into 1 is 0. 2 plus 0 is 0. The next line 0 plus 0 is 0. The next one is 0 goes directly, whereas here for this third line 2 comes from here and 0 goes directly. So 2 plus 0 is 2, whereas the last line the input comes from here. So 0 plus 0 is 0. So the output sequence is 2 0 2 0. This is a 4-point DFT. Sorry, 4-point FFT. Next, this is another possibility of problem. See, no matter what is the algorithm given to you, check the two differentiating points. One is the butterfly structure and the other one is where we have to place the Twiddle factor. Okay, so computing the DFT of the sequence x of n is equal to, this is actually a very important problem, cos n pi by 2, where capital N is equal to 4 using DIF FFT algorithm. Now they have given cos n pi by 2, but they have not specified the values, right? So in that case, n equal to 4. N equal to 4 in the sense n takes the value 0, 1, 2, 3, right? So substitute n equal to 0 in this sequence. So 0, 1, 2 and 3. If you substitute, we know the cosine values, right? So calculate those cosine values and find out the values, right? Now, how the input has to be placed in DIF? Do you remember? It is in normal order. Normal order, bigger butterfly at the starting. Twiddle factors have to be multiplied after the butterfly, right? So the same procedure, but exactly vice versa we are doing it. So do that. You will be getting the answers, whereas the answer will be there in the bit reversed order. You might be surprised why madam is repeating so many times bit reversed order, natural order, bit reversed order, natural order, but that is the most important thing, or that is the most important place where you commit mistakes. All will process all the things correctly, but at last while writing the answer you will make mistakes. Okay, so in the output you have to while writing the output you have to bring it to the normal stage. Okay, right. What is inverse FFT? So after explaining so much of thing, we have already told DFT is an exact Fourier transform pair. That is, we can calculate, we can convert the time domain sequence into frequency domain, whereas frequency domain sequence can be converted to time domain sequence. Is it not? So in the same way, and I have told you already, FFT is simply to reduce the number of computations that we are getting in DFT. So the same possibility of obtaining the vice versa is possible by using FFT. So the trial is what is our inverse FFT algorithm. Inverse FFT algorithm in the sense, let x of k be the endpoint DFT of length n sequence x of n. The inverse DFT, this we know already the formula. How can we obtain the same thing using butterfly structure? Ma'am, now I am very convenient with this butterfly structure. Please tell me a procedure to execute the same thing by using DIT and DIF. Yes, it is possible. An FFT algorithm can be used to compute the inverse DFT by replacing x of n by x of k, taking the negative powers of Wn and dividing the output by n. So these two are very important points. Probably it is theoretical. I'll show you in the block diagram. Hence, in order to compute the inverse DFT from an FFT algorithm, following steps can be followed. First step, take x of k as the input sequence and x of n as the output sequence. So this is the first point. X of k has to be taken as the input sequence and x of n has to be taken as the output sequence. Compute FFT by replacing the Twiddle factors. There in normal algorithm we used Wn as Twiddle factor. Here the only difference is we are going to use Wn to the power of -1. At last, obtaining all the outputs, divide the output sequence by capital N. So DIT algorithm becomes DIF inverse FFT algorithm and vice versa. For example, DIT inverse FFT butterfly diagram for n equal to 8. So I am going to show you an n equal to 8 algorithm which is going to be as follows. So what is the first step? Take x of k as the input. So we have taken x of k as the input. So x of k is taken, whereas the output is there in the bit reversed order. So what are the procedures? This is actually using DIF. Sorry, I made a mistake. This is using DIF algorithm, right? So DIF input is in normal order. So we have placed in normal order. What is the only difference here? We have to multiply it by the Twiddle factor Wn inverse, Wn to the power of minus. Simply include a minus symbol in the whatever you have, simply take the inverse values. Okay. So apply the same procedure, take an inverse. After calculating all these things, last step what you are supposed to do? Divide it by n. What is the value of n? N is going to be 8. Okay, so divide all the values by 1 by 8. The input sequence will be there in the reversed order. Change it to the normal order. That will give you your time domain sequence. So this is the same thing we do it for DIT also, right? So with this, the session is getting over. Thank you so much. Yeah, one thing I have left. So these are the possibility of assignment questions. Some of the questions which are not relevant to this topic is also added. So better leave that. But it is not relevant to your subject. It is relevant to this particular topic. Probably it will be useful for the other topics. So these are some of the problems. You can try it on your own. And if you have any doubts, please do contact me. So these are some sample problems.